Okay, we'll kick things off for the afternoon session. A few people still milling around, but hope you all had a good lunch and a good catch-up with everybody. Firstly, thanks to my colleague and friend Peter Simpson for this morning. Nice little round of applause, please. Thank you, Peter. Set a very high bar for me this afternoon. A couple of things first. So, there's these forms kicking around, which are the feedback forms. Now, these are really important, and they do get used. And I think Judith told me this morning that she phones people up as a result of these forms. If they're not happy, that is, if they're not happy. So please, if you could complete your form. Do they leave it behind, Judith, at the end? Yeah, leave it behind somewhere here. Okay. Okay, I'll leave it on the tables or whatever. Great, thank you. And the other thing is, we've got this... oh, it's not gone, actually. Can you put the chart back up there? Yeah, we're still doing a couple of these votes here using Slido. I don't know whether people are missing the hashtag thing to get into Slido, but we've only got 51 people voting for this one so far. And we've got another one on there as well, which is about the 2050 target. So please, can you... tap in there, and maybe we'll have a look at both of them at the end and give people a bit more time to have a vote. Okay, so let's press on with the afternoon session, and I'm going to be handing over to Jez, who you all know very, very well. So he had one introduction this morning already, so I'm not going to introduce him again. But I'm going to ask Jez to tell you something that you don't know about him. So Jez.
Surprisingly, no. So in fact, what I am going to do is I'm going to name check someone. And everybody's now getting slightly nervous. The bit is I've been in the industry for nigh on 30 years now. Although most of you know me from SES, originally I started at South East Water. And at the time they were going through a merger, they joined together from kind of Eastbourne Water and Mid-Sussex Water and West Kent. And we all ended up down in Eastbourne working together. And it was a bit of a difficult department. And I was a green behind the ears graduate trying to find my way and trying to work out what I was meant to be doing. And I had a boss who came in and he just transformed it in 2 years. He was fantastic. He just turned it around, and he was the first person that really kind of picked up on me and just went, Jez, I really think you can do stuff, you can invent stuff, you can come up with new ways of doing it. And he was the person that really inspired me to just go out there and try different stuff. And to this day, that's what I've been doing in the industry. I just keep trying different stuff, and some of it works and some of it doesn't, but that's what we've got to do. And so I do just want to name check you. Jonathan Archer at the back there, sitting with a tie.
Jonathan, would you like to stand up and take a bow,
Jonathan,
please?
thank you. Yeah, that is the man you have to blame for me.
Yes, I'm going to say you get a round of applause for putting up with Jeremy for such a long time.
So there we go, that's from me.
Great, thanks, Jez. Jez is going to manage the Soapbox Challenge, which is going to be about, just under an hour or so, and a number of speakers. So, Jez, I'll hand over to you. Thank you.
Yeah, thanks very much. And can we have the speakers up here? So can we get John, Khalid, Bradley? Can I have you guys sitting up on here, please? That'd be fantastic. I see you making your way to the front. Good. So, we've spoken earlier about innovation. And I've said, look, innovation is not the magic pixie dust that is going to solve all of our problems. But it is vitally important that we do have innovation. And when I talk about the magic pixie dust, by that I mean there's not one solution. There's not this little button somewhere that we just flick and that solves leakage. What we need is lots of innovation coming in, lots of new products, lots of new developments that are coming through that are going to change and transform how we do leakage. And what we need on that is we need a broad front of that. Okay? Some years ago, you'd be approached by suppliers going, I've got the solution that would solve leakage in your company. No longer do we get that. We get people coming through the door going, I can help in one particular area, and that's what we need. You know, we keep coming back to that PALM, prevent, aware, locate, mend. In each of those, we need new technologies, new solutions coming through. And particularly at this time. One of the things we've been talking about this morning is this thing about background leakage and the fact that we have got to change how we think about that. We've got to understand it better because that's a key part of where we're going to be going with those adaptive pathways. And so part of this innovation that we've got to see coming through is going to say, okay, how do we understand the leaks that we don't know about at the moment? And some of the technologies we're going to be looking at this afternoon are going to be helping us do that. How do we find those leaks that at the moment we're really struggling to find? And when you talk with the leakage manager, they go, that's not really important. I'm sure they're pretty small, they're pretty tiny. Actually, those leaks are now becoming increasingly important because we need to understand that background level of leakage. Okay, we need to have a far better handle on what's going on. And I've talked with water companies that are going, do you know what? We are literally there with our ALC. There's not really much more we can do with that. We've got to start bringing in new and better ways of doing stuff. So that's where we're going to be going. Welcome up here. What I'm going to do is I'm going to give you 8 minutes of speaking. I've got my phone down here. So I'll give you 8 minutes of speaking and then 4 minutes of questions, okay? And then if there's any time at the end, we'll have a quick open round session of questions, okay? So that's going to be the kind of format for it. It's going to be short and punchy like that. As they're speaking, get your questions in on Slido. I've got my tablet as well. I am multifunctional up here, so I'll be watching your questions come in. So we'll do those as well. But if you don't do any questions, don't worry, because I've got plenty. They do say in my office that I'm not normally allowed coffee during working hours, because apparently it makes me act like Tigger and talk a lot. But for you lot, I'm having some caffeine. So thank you. Over to you as our first speaker, John.
Thank you, Jez.
There we go.
Good afternoon, everybody. Okay, thank you, Jez. So I'll just press this, yeah? Okay, so this is about data, this presentation. In fact, it's not actually about data. It's about how you use the data. It's about managing a situation with data. It's about the rewards that you get for using data well, or it's about the consequences from not using data well. This little talk will feature safety, the economics of what we do, and also sustainability, which of course is the big question of the moment. So, I'm not going to bang on about what we do, but what we do is the hydrostatic pressure testing, part of the commissioning process for new water pipelines in this country. Now, we've heard an awful lot about leak detection, and that's absolutely right and proper that we do. But this is the other side of the coin. This is about leak prevention. This is about doing what Joe was talking about this morning and making certain that we don't put leaky pipes back in the ground. That's the main thing. And we monitor this sort of stuff. And our mathematical models allow us to really drill into what's happening, and we can go above and beyond what a lot of people can in this particular sector. So here are the figures. Now, my eyes can't really see that from here, but you can see what sort of things are happening. This is the last 2 years of data, so it's COVID effective. So when we pressure test, and our pressure test is a managed service. So contractors come to us and they say, right, Antire, we've got a test that we need to put on test. Will you manage it for us? And this is what we do. So we find that about 60% of tests that carried out in the last 2 years passed, about just short of 20% were leaking, and about 10% were stopped for air. And you can see a little graphic on the bottom right-hand side there that says how much of the length of pipeline that we worked with was actually pushed to compliance through our intervention. This is lifetime intervention. Okay, here's some of the data. We've got plenty more, but not time to show you all. This graph, the yellow one, shows the number of tests it's taking us to achieve a pass. Now this data is for AMP6, so this is for the 5 years, April 2015 to March 2020. What we're seeing there is an average number of times to achieve a positive test, a successful test, 1.1, 1.2 at the beginning of the AMP, and curiously at the end of the AMP we're up to 1.7, 1.8. We've got worse at what we're doing. Now there are a number of factors for that, not least the number of new entrants and an enhanced number of tests that are being undertaken as the AMP progresses. We can drill down into that data. We hold all this data for a number of years. And this again is that data represented in a slightly different format. This shows the number of tests undertaken in that AMP period, but also which ones are passing and which ones are failing. And curiously, we've got a point in the middle where up to which we're seeing like a failure rate of something up to about 20%, and the latter half of the AMP we're seeing between 20 and 40%. So we need to know what's going on. We can drill down into that even more. So here we are. This is failure modes. Now, same time period. The blue is leakage. That's predominantly what we're tasked with doing. But secondly, it's a safety issue, and that's the red. So blue and red are our key areas of interest. The other areas of failure are typically all down to operator error or failure to prepare properly before the test. Now, if we look at one of those bars there, I'll take the highest one, which is June 2019. Guess what? We can drill into that a bit more. And this is what it tells us. Now, this has been redacted. These are the contractors, 30 or 40 of them, who registered failed tests with us in June 2019. And you can see there from the color coding what exactly those failures entailed. Now, this is wonderful information that we can use to improve the quality and standards of what we're doing. But I'm not convinced that enough of us are taking the opportunity and doing exactly that. The rewards are there, but the consequences are we're not doing anything and we fail because of it. Now, there's one of those bars there that I'm again going to look at, and it's the one in the middle, blue and red one in the middle. Guess what? This is one particular contractor. Again, it's redacted for obvious reasons. This particular contractor, you can see there's 5 operators there. What a fantastic opportunity to help those operators to do better. What a fantastic opportunity to work towards the holy grail, if you like, of only undertaking one pressure test at a time and getting a pass on every occasion. Finally, safety. I say finally because it's the final slide I've got. The slide on the left shows air content. And the national standards provide for up to 8%. A lot of companies go for 4% because it's much safer. But the 2 main reasons why we need air content down. Firstly, testing with 0 air content gives us the most effective test conditions. It means we're going to get the tests off first time more often. It's not the easiest thing to get all the air out of a system, but it's certainly the most effective way of getting an efficient test done. Secondly, is a safety issue. Air is a compressible fluid, and when it's fully compressed, has something like 20,000 times the energy of water at the same pressure. So, when one of these pipes goes off, as it did in 1988 for a gentleman called Paul Noon, some of you may know him. He was known as Flipper after that incident because he lost half his foot and quite a lot of his leg, and has lived with that since right up to this day. Now, Paul was quite happy for me to share that detail with you, but he did acknowledge that a lot's been done to improve safety these days. But our records show, and I think the health and safety executive know, and I suspect there are probably people in this room that are aware that dangerous situations like this continue to happen. So, some final points. The vast majority of people that use the pipe dashboard, that's where we keep all our data, are bought in. They understand the benefits, they understand the opportunities, they don't see any downsides. It's driving...
1 minute.
Thank you. It's driving safety and efficiency gains. Having said that, there are people that fail to register a successful test. So, for example, here, 369 failed tests on 222 sites during that AMP period, never received a positive test pass. What happened to those tests? Where did they go? We know who they are. Were those tests ever completed? Well, we don't know. One contractor came to us and said, I've been directed to undertake 7 pressure tests a day, which, if anybody knows anything about it, is impossible because they have to be on for an hour minimum. And these are the sorts of things we're seeing. There are instances of falsified certification. We're seeing things that look very like our certificates out there on the market. Now then, the Scottish Water model is a little bit different. So what Scottish Water does is it has the final arbitration over whether a test constitutes a pass or not. And there may be some water companies in this room that do that, but I suspect a lot do not. It's maybe something we should be looking at. So finally, with no data, we can't understand what the national picture is. 50% leakage target for reduction is a massive figure. Now, granted, we're not going to be able to contribute a massive amount to that. But as Dean said this morning, Dean Marshall he said, this is about marginal gains. We don't know how much we can contribute until we know how much bad the picture is. So we need to measure more. We've got environmental and net zero 30 concerns, and we are compromising safety to this day. Cost and efficiency opportunities are there to be had, so why aren't we taking them? There is a win-win-win for everybody concerned. So my question is, why don't we do more about it? Why don't we embrace this technology more? Or maybe it's time for some sort of regulation and forced compliance. Thank you very much.
Wow. Okay, so I'm going to say stunned silence, to be honest, because... So look, let's go back on Palm. And I know I keep coming back to that, but the reason I mention it is because when we first started doing these conferences, or you know, up until quite recently, we were always focused on that kind of awareness and location, and you come along to places like this and they talk about, you know, logging and things like that. And don't get me wrong, those are completely important to what we're doing. But a key part of what we're doing is prevent. And if we can't put pipe in the ground without it leaking, we're on a hiding to nothing. And particularly if we're putting plastic pipe in the ground, because we know how hard it is to find leaks on plastic. We've got to get this right. And John, I'll be, you know, you and I have had this conversation already, but I was horrified when I saw those figures. 20% of tests are actually showing that they're leaking on brand new installed pipe.
Certainly up to 20%, yes, absolutely.
And let's just clarify that. This is before they've even tapped the pipe, isn't it? This is where you've just got a plain pipe before they've even started to do connections.
That's right, that's correct.
So it's going to be even worse, because effectively, you know, some of your connections are going to leak as well. If they don't get those right, it's actually going to be worse than that.
So the data that we have goes back quite a long time, and we've refined the data over the years. So we're getting more and more accurate with the sort of measurement that we do. We have a pro forma system of requesting this information from the customer, from the operator, from the construction company concerned. So we rely on that provision of data in all fairness. But yeah, it's somewhere up to 18% is what we're finding leaking.
So I think my question straight away, you know, for you, those of you who are leakage managers in your company, is going back and starting to ask some really difficult questions about what's going on there. And you know, am I right, and I'm just conscious of time, but am I right in thinking there's two kind of things here? Number one is, it's about getting that data from existing systems that are being laid at the moment and making sure that we can actually get some kind of quality assessment for our contractors, that they're actually getting that feedback. Is that stage one?
I think it is, Jez, yes. I think what you're doing here is, you know, these tests, these pipes are being put in the ground, and on the vast majority of cases, tests are being undertaken, but not always in the right way. So the water companies are paying the contractors to do the tests. So why not get them to do it right first time? Why not get them to have register the accountability of, like, saying, here's the proof of what we've actually done. Here's the evidence of what we've done on this particular site, because that would prove that the job had been done right in the first instance.
And then the second bit on this is, okay, you know, they've laid a pipe and it leaks. Yeah? Surely there's something that we should be doing in terms of accreditation of people that are actually working on that pipe, fitting that pipe together, in order to make sure they can do it without it leaking.
Yeah, so there's the EUSR numbers. So one of the standard questions that we ask of any contractor, that ring us up and they say, right, yeah, Antire, we've got a pipe, it's ready to go, and one of the questions is, what's your EUSR number? So that accreditation shows us that they know what they're doing. They're accredited to know what they're doing.
They are, in terms of, and I agree with you, they're accredited to know what they're doing in terms of being in contact with water. Yep. I think the bit that I struggle with is, I know that on the continent, to join pipes, you need to be accredited to actually join pipes. And yet in the UK, there's no accreditation for people to actually join pipes. They receive training, don't get me wrong, but there's no national accreditation system that says you are qualified to join together plastic pipe properly. And I think, you know, certainly I've been discussing with the CEOs in the past about whether we need to look at bringing in accreditation. I think my takeaway, thank you, John, really, really useful. I'm sure you get some really good discussions, but my takeaway from that would be, everybody that's involved in terms of the water industry is going back to your companies and going, what's the figure? Go and speak to your service delivery, the people that are laying your new plastic pipe and your new developments, and going, how much of that is failing those tests? How much of that is leaking? Because as fast as I'm repairing them, you're generating more stuff for us. We've got to get a handle on that. Okay, look, thank you very much for that. I know there's some other questions here. If we've got time, we will come back to those. Just checking which one we're on to next, and that's going to be Khalid. Khalid, over to you.
Thank you. I'm going to have my own timer as well. Hi, afternoon. My name is Khalid. I'm the chief scientist of a tech startup in London, and we're called Sensat. We data capture, we fly drones, we commission satellites, we do LiDAR. Our main aim really is to turn your sort of physical world or assets or infrastructures into extremely high detailed 3D replicas. And then we sort of have a platform, web-based platform that could actually allow you to visualize all of that with your designs and everything else. And then we have what we call a solutions factory where we get close to the clients and we solve problems. That's where we do fun algorithmic stuff. We're mainly a sort of a construction tech company. So we've not been part of the water industry for that long. In fact, very, very new in it. So we target pretty much all plan, bid, sort of manage and sort of all these phases of different construction sites or infrastructure. So we were quite familiar with those. Water industry is new to us. Leakage is new to us. But we like it because we like a bit of a challenge. Our main aim really is to autonomy. Autonomy is the key in the construction tech. We want everything to be autonomous. We want to get there where pretty much it's robots doing all the dirty work for us. But that's a long way to go yet. And I think the AEC industry in general, and this is my personal opinion, that we're sort of partially autonomous at the moment, but we've got a long way before we actually start to gain some good ROIs from even thinking about what that looks like. And there's a huge amount of technology within it. So leaks. Coming to the leaks, as I said, there was a need to it. We were given a POC to do. They said, oh, okay, turn this infrastructure of ours into 3D and identify where the leaks might be happening. That was it. So we basically sent out our team to capture the data. We did sort of multi-spec thermal surveys. We flew drones, captured the information and the site itself. And then the three inputs that went into the AI were pretty much the orthomosaic data set, so all this pretty RGB, very high resolution, around 2 centimeters. We can go higher, but that was enough for us. We look at localized flooding because we were pretty much looking for surface water and surface anomalies. And we were looking for thermal anomalies because wet soil is cooler than the drier soil, sort of. So we created these sort of machine learning models. We basically said to the models, go and tell us where the leaks really are. Now, we're not leakage experts or we're not water industry experts. So it was quite daunting for us to say, oh, how are we going to sort of optimize our models to be able to look for certain type of anomalies? Well, we actually didn't. We created the models. We said, okay, look, this is what the leak looks like. This is all the data set that we've given you. Go and find us similar sites of that nature later on. So what it does is that eventually it goes in there, goes through multiple iterations, loads of iterations. But that's the power of sort of nowadays cloud, that you can throw compute power at these algorithms and they just go boom. So at the end, it creates what we call a sort of a leakage probability map. So it's always, statistics. Eventually, all AI is fancy statistics, right? So it creates a probability map. So this is a type of localized sort of flooding and micro sort of a topography that we were actually looking at because we wanted to see that if the water saturation caused by a leak and an asset underground was any different from a natural flood appearing in a puddle. So we were looking at some microtopography. We were looking at thermal data sets. And if you visually look at that, that looks very messy because it's extremely high resolutions. This is, I think, about 1.5 to 2 centimeter resolution. So you see a lot of different changes happening. We like it, pretty pictures. We can actually sit down and say, ooh, what's that? Or what's that? Is that a leak or not? But algorithms are very good at picking up those things and then correlating all of these multiple dimensional data sets. So we did that. And then this is the first sort of iteration, first results that came out. This is what areas are showing you of, I think, 50% chance of a leak. So it was, yeah, I think we think it's somewhere here. So then we went through a few more iterations to refine it, and then it's 70% or more chance of the leakage in those red areas. So there's some interesting patches appearing, and then we suffer. This is basically obviously based on the data only. We then had to sort of validate some results, and that was quite interesting validation, because you go back and site and see that if those leaks can be validated, and quite a few of them were actually validated. The interesting thing about these algorithms, the AI is always taken as a black box, that, oh, we just throw things at it and it's going to do magic and then something's going to come out of it. Even the experienced data scientists, they sometimes think that, oh, I don't know how. It's multidimensional data going in, so I don't know how he actually got the results, but the results are pretty good. So what we also do is with our algorithm is that we actually tell the algorithm to try to explain to us that why you thought that there was a leak there. So if you're making an inference, if you're making a prediction, then please tell us what could be the reason. So two major criteria that it actually picked up on a few data sets we provide was obviously looking for thermal anomalies and disturbed vegetation. So that was the two key things what the algorithm was doing. We think it's still naive, because if vegetation is disturbed and it's cold, doesn't mean that there is a potential leak, but there's next to it. So there was another leak that we actually looked at that got picked up by the algorithm. There's a bit of noise in here as well, but that got sort of filtered out later on. Was it perfect? Of course not. It was just the first very quick iteration. To give you an idea, it took about a few days to train the model and then sort of get some results out of it. The data was quite large. That's what they struggled with, quite a few tens of gigabytes of data set. So, but it was not perfect. But it was quite alarming that it's giving you areas that are quite close to it. Very valuable to the client. What's next? Well, what's next? Well, we now know there's saturated ground. We know it's anomalous to its surrounding. We know it's not caused by the localized flooding, but we still don't know if it's actually a leak. So the next thing what we're trying to do is that we're basically doing a bit more multi-spec or even sort of a radar. We just basically say, okay, this is the 70% chance of a leakage area. Tell me what the content of that leak really is. Is it chlorinated? And that could be done by satellites pretty much. You know, it don't have to be drones. Or even any other content of that water. And then that will then improve the accuracies over time. I still don't think that's the true answer to finding leakage, because there's a lot of good stuff going around in pressure sensors as well. So it's a combination of all of those that eventually we will get. Thank you.
Khaled, thank you so much. Khaled, grab a seat and let's go through some questions. And
I don't know why I'm taking
I'll leave that there. That's lovely. Thank you. So, really, really interesting in that, you know, so when we did the leakage innovation heat map, so this was a survey of all of the water companies, and we said, okay, where is your innovation going? And one of the areas we looked at was location, leak location. And we kind of broke that down into acoustics and non-acoustics. And what was really interesting is that there was a load of work going on in non-acoustics, okay? And that was very interesting, because traditionally in the water companies, you know, 3-4 years ago, you came along here and everybody was talking about acoustic networks and things like this and sweeping those through. Birmingham just here has got massive acoustic networks and things like that. But there seems to be this real drive towards non-acoustics at the moment, which is, you know, pretty much where you're going as one of the non-acoustic technologies. What do you see as the advantages there of the non-acoustic methods?
I think one of the advantages of methods like that, especially non-acoustic, that we can actually cover a larger area, a huge amount of area, and then just throw the data at the algorithm and say, go and tell me. This could be done by drones, which relatively sort of smaller regions that they can cover at a particular time. But imagine satellites. You know, the satellites nowadays are even sort of, you know, commercial satellites, which are not as expensive as people think, 25 centimeter resolution. You know, if you can find out you leak at that sort of a spatial resolution, you're all fine, right? So imagine, and then satellites are going over like every other day over us, and we've just not managed to tap that Earth observation potential. So there's something already there. So I think it's one of that you can actually truly identify exactly where the location of your leak is, but at the same time you can cover a huge amount of area with that particular method.
That's really useful, thank you. And the other bit, obviously, with any kind of technique like that, and I do love that kind of whole AI approach in terms of you just say, look, tell me how this system is connected, tell me what's going on. It doesn't have to know how that works, the nuts and bolts, just show me the connections between it. But always with things like that, that training of a system as well really helps and improves that solution. So how do you do the training on this? How do you deal with that?
So there's a combination. So I'm going to suffer diverge and come back. AI at the moment is slightly broken. We keep thinking about AI being this supervised learning that has to be trained. Well, it doesn't have to be trained. There is other branches of AI and machine learning that are unsupervised. So you don't have to train them. You just have to say that, oh, you know, this is a typical signature, which in this case was that, client had identified that there definitely was a leak at that time there. We said, okay, there's your signature. Go and find that signature everywhere else. Don't need to train. So this is just the only data set that was given to it. So there are a huge potential for non-supervised learning as well. You can train them as well. That means you have to have a lot of data set.
I had a really good question come in here, and it's something that I was going to ask anyway, so whoever put this one in, thank you very much. But are any companies looking at sensor fusion solutions, combinations of pressure, visible inspection, acoustics, thermal, electric, and such like? Is, you know, that kind of integration of data together, is that something that you feel that's kind of where you'd be able to take this, by fusing data together?
Absolutely. I think it's happened in other industries as well, manufacturing, agriculture, fintech, you know, multiple data sources came in. And that's why I've actually put the last bit in there. This is not a perfect or the only solution out there. I think solution is sitting in the combination of pretty much all the knowledge that's sitting in here. Yes, the sensors are important to identify certain things. We just need to identify what sensors are good at, what software Earth observation is good at, and what other methods are good at, and just put a solution together, shake it. I think that's where the combination is the power of it.
I know you're in trials at the moment, but what are you looking for from the room? Go on, what would you want?
Look, we have clever minds pretty much everywhere in my company as well, and we have the answers. We just don't have the questions. You guys are sitting on those questions and problems. So we want to know about those problems, and the solution will come.
Khaled, thank you very much. Bradley, over to you. So we've talked a little bit about background leakage, okay, and about the issues about how we get down and start to get that kind of understanding. And I really liked it when I was looking at your website. You have a great tagline on there, which effectively, and I'm going to paraphrase, finds the leaks other things can't.
Yeah.
Okay, which was really good. And I think that to me is, you know, I think if you stood up here 2-3 years ago, people would be going, well, I want to find the leaks that I can at the moment. But I think that we're having to push into these other areas. So I'm really interested in your solution. Bradley, over to you.
Thank you very much. Good afternoon, ladies and gentlemen. First of all, obviously Electroscan, we are a leak detection and pipe condition assessment company. And the technology that we use is focused electro leak location, or FEL for short. So basically, in simple terms, we emit an electrical current into water. So we do what basically you were told not to do when you were kids. As our probe is going through a pipe, obviously surcharged, we're acting under Ohm's law, and when we come across a defect in that pipe, we turn to Torricelli's law. So the easiest way to explain this is if you imagine a light bulb. When we come across a defect in that pipe, we measure how long that light bulb stayed on for, and we measure how bright that light bulb got. This enables us for the information to come back to our system, quantify the data, and we can actually give you an estimated defect flow rate in litres per second and litres per day. So a quick layout of how actually one of our scans will actually happen. As you can see here, this is our tethered solution. From a van, we also have a push rod system. And obviously, like I've said, as you can see, as the probe's going through the surcharge pipe, as it comes across a defect in that pipe, the electricity will escape, travel back through to our grounding stake, and come back to our voltage source, which is our van and our software. Some of our advantages for using, obviously, machine intelligent non-acoustic technology. We're not affected by ambient or street noise, high groundwater or low water pressures. And after a scan's been completed, we upload our scan via our Wi-Fi and our vans through T4S up to our Amazon Web Services cloud system, which then pushes it onto our critical H2O software. Our critical H2O software is the software that quantifies the data, and then it's pushed back to the client and the operators in the ground within 10 minutes or less. So here's one of the basic reports that you'll get. On the top left, you can see the defect count. So obviously this gives you the number of defects and the classifications of those defects. Next to that, you can see the total defect flow in litres per second and litres per day. Next to that, you can see the diameter and the distance, and below you can see the pipe defects that were picked up on the graphical display. So some questions that we get from clients that we've had in the UK and the EU. One, is it going to affect customers' houses when we put electrical current next to their house? No, it doesn't. The power that we actually put out of our probe is probably the same power as a pack of 6 AA batteries, and it will dissipate in less than half a metre. The other question we get asked is, do we get affected by electrical interference? Again, no, we don't. We actually done a trial. We went to Ginza Station in Tokyo. We actually done a 1,000-metre survey using one grounding source, and electrical interference was not detected. So when we want to talk about repeatability and things we're looking at for innovation, as you can see on the right-hand side, our probe is moving up and down a see-through pipe continuously. Each red dot is a defect in that pipe. Now, if you look to the left-hand side, you can see our graph is picking up each of those defects as it's going forward and backwards. And as we zoom into that scan after, you can see that using both the laws, defect 1, 2, 3, and 4 going forwards is the same as defect 4, 3, 2, and 1 going backwards. So obviously this gives Electroscan that unmatched data repeatability. So how do we achieve that 1 centimetre locational accuracy that we claim on our website? With our conductivity probe, we have a tri-electrode system. So as our center defect node emits that electrical current and starts spreading out, our forward and rear defect nodes catch that current and push it back towards the center, forming a flat disc. That gives us our 1 centimetre locational accuracy, and then gives us, obviously, like you see the results below. So obviously with this new approach, we actually can eliminate the variable of C in the hole, and we can now actually look at measuring the size of the hole instead. So I just want to quickly go through some of the products that we have, the specifications on all the products. You can come and see our booth afterwards in the break. We've got product catalogues and we can go through everything with you. We have the Delta, which is our tethered van system. We have a 1 kilometre cable on that, and we can handle pipe diameters from 150 to 1500 mil. That has a foul probe on, CCTV, and an acoustic. The Trident is a push rod system with 120 meters of cable on, and has a foul probe and just CCTV. Delta and Trident are currently being implemented into Anglian Water with the help of James Hargrave, so thank you very much for that. And the 2 new products that we have brand new on the market is the Swordfish and Kingfisher. So the Swordfish and Kingfisher allows us to assess pipes now from 25 up to 75 mil. So now we're focusing on customer side DMA level, accessing Atlas boxes. This was actually designed because we were actually asked by an employee at Thames Water if it was possible if we could make something like this. So that was actually the result. At the moment, around the world, we actually currently have a lot of major international projects either on the way or currently underway. We also have a lot of sewer stuff as well. Electroscan's recent awards. Last year in June 2021, Electroscan was awarded Top Product of 2021 by the Environment and Energy Leader. In November 2021, Electroscan won the Petronas Technology Challenge for inspection techniques of underground piping. And January this year, we were awarded Leak Detection Solution of the Year, second time in a row through IoT. Thank you very much. That's the end of my presentation.
That was great on timing as well.
Thank you very much.
Thank you.
Thank you.
Thanks, Brad. That was really good. And I'm changing to calling you Brad now because I can see that I'm allowed to do that.
Yeah, that's fine.
So, Brad, a number of questions are coming while you've been speaking, but let's kind of start with that first one, is the UK water specific. Obviously, we take our hydrants, we bury them nicely underground. We have things like fixed jumpers on them, so sometimes it's really hard to get something. How do you get your device into the water column? What's the best way of doing that?
So we have a few access points that we can actually get into. Gate valves, air valves, hot taps, and predominantly through-bore hydrants. Obviously, it enables us to have direct access straight into the pipe. At the moment, we are experimenting with the normal standard hydrants, and obviously the American side have adapted their technology to actually access their fire hydrants. So it's just a case for us at the moment. We have a limited variance of what we can actually get into, which I would happily go through back at our booth. And it's just more of experimentation, seeing how we can adapt the technology.
And, you know, what pipe materials are you finding this works best on? Are you going to say everything, or is there particular pipe materials where you recommend it for?
We will say everything, but our best material we work in is PVC. A lot of things we're getting from utilities now and subcontractors is that foul works best in PVC pipe. Now, everyone says, you know, it's hard to find a leak in PVC pipe. At the moment, that's great for us because we've been benchmarked to find leaks in PVC pipe. So, yeah, I'd say that's probably our best material that we look at.
And I can tell you right now that there's probably a dozen managers out there frantically emailing through going, I think I found something at the conference. Okay, PVC pipe, huge problem in the UK. I know it was in the States as well. Yeah, that's very, very interesting. For those that don't know, PVC pipe is a particular problem because when it was introduced as a wonder material. And it was put in with crowbars because you could, which puts stresses on the pipe, which can then fracture. It's really susceptible to UPVC, so they put a nice little pile of pipes by the side of the road ready to fit them, and the one on the top would get all the UV, and that would be the one that would fail in about 5-10 years down the line. So it is a huge issue in the UK, so I'm really interested in that. Just had a question about, obviously, when you're pulling something down the pipe, you've got the delta, you know, the kind of deploys down there. Do you find that causes sediment issues at all, or...?
No, so we've done turbidity tests, and obviously we've passed them in the past. Obviously, we're constantly assessing as we're scanning anyway, both with the Delta and the Trident. You know, we have done tests with Trident in the past where we start seeing tuberculation levels getting high, and obviously we then reassess and say, right, we're going to stop here and not go any further because we don't want to cause a pollution incident. And the same with Delta. Every test that we've done, we've had turbidity sensors in there. It's not actually picked up anything and caused any incidents. Touch wood. Not yet.
And so, yeah, the bit, just wanted to kind of follow on from that. What's your model for deployment of this? So, because you've got to introduce something into the pipe, that's quite intrusive, and, you know, I think a lot of managers will be going, I can't run that out across my entire patch, okay? So I think there's a couple of models that will come off the top of my head, and you're going to go, okay, I'll do it for the bits that I know are worst. Yeah, I'll do it for my PVC pipe network where I'm worried about it. Or even I'll do it on a percentage of my DMA just to find out what my background leakage is and then scale that up across the entire DMA. What's your model that you're thinking of?
So we've been approached, obviously, like you said, about a percentage of a DMA, and said basically if we were to give you that area and investigate it, you know, what kind of results do you reckon we could get from that? So we've had that in the past. We've done service agreements. For example, I'll name Southern Water and the Government of Jersey. The Government of Jersey handed us last year 18 kilometres and literally just said, do half the island. That took us just over a month. And Southern Water, we've just completed a 51-kilometre survey, but that was for sewer, not for clean.
Brilliant. Thank you so much for that. Really interesting discussion. So your stand is there, isn't it? I saw you basically come in and just keep walking, I think.
Yep.
You're on the far side, aren't you? So there we go. I'm sure you get a load of people coming up and grabbing brochures on that one. Anybody with PVC is going to be beating apart your door.
I want to see at least one person take a baseball hat. No one's taken one yet.
Oh, seriously? There's baseball hats?
Yeah.
Oh, I'm going to be there. Right. Right. Now, finally, We have joining us from Canada. So here we go. This is really going to be the innovative bit. Now, we wouldn't have been able to do this kind of stuff a few years back because none of us were capable of doing remote working and things like that. But hey, the world's moved on. So all the way from Canada, we got Nathan. He's going to be talking about AquaSense. And really, really interesting bit this is some of the technologies that they're bringing in with this one to try and solve a problem. And it's one of these ones where I'm really interested in what the room thinks about this. I think there's some real applications in here, but we're going to have to think about how we use this and how we deploy it. So Nathan, hopefully I'm going to say, are you there, Nathan? He's just coming, fantastic. So he's on his way, and there he is. Nathan, lovely to...
My name is Nathan, and I'm here to pitch for AquaSensing. We are a water leak detection startup out of Waterloo, Canada. Slide. The main piece of technology that we work on at AquaSensing is the battery-free water leak detection sensor, which is the first of its kind for water leak detection devices. Typically, a leakage sensor has a sensing mechanism, some controller or processor, a wireless radio, power source, and power management electronics. However, our sensor does not need any sort of power source. Instead, it relies on the water itself. We eliminate the need for many of these components to produce an ultra-low cost, bare minimum, low maintenance, highly scalable leak detection device. And what's more is we can eliminate the steady stream of battery waste to the landfills. Slide. Right now, most of our focus has been in the residential leak detection space. In multi-residential complexes, there is potential to install dozens to thousands of sensors in a single building. A user places a battery-free water leak detection sensor anywhere high risk. A local gateway relays data to our cloud, which alerts a user remotely to any leaks happening. Because our sensors are battery-free and require no maintenance, you can put them behind permanent walls, in ceilings, without worrying about costly and disruptive battery replacements. The low maintenance and simple installation are what make the sensor ideal fits for scalable leak detection applications. Slide. So next we turn to water leakage in the UK. Infrastructure is old and degrading in many places, and leakage reduction is a challenging task. Leakage estimates are around 3 billion litres per day, which is 20% of the supply network water. The goal by 2025 is to reduce this by 15%, and then by 2050, another 50%. Although many targets have been set, historically it has been challenging for utilities to meet them. However, the incentives to reduce water consumption are growing, and leakage reduction is a necessity to secure water resources for a sustainable future. Slide. There are a number of challenges faced when trying to reduce leakage. For example, to lay new pipes in place of old ones is incredibly expensive. Active leakage control is also high cost, and UK water industry research points out there is a lot of uncertainty around forecasted costs to intensify these efforts. The pipes used from mains to individual homes come in a variety of materials and sizes, making leakage detection with existing acoustic methods challenging. Moreover, leakage reduction is not a one-off cost, but instead an ongoing effort, increasing operational costs for utilities. We can help with 3 of these issues by implementing our sensor devices, which offer a low-cost, low-maintenance solution that works independent of pipe material and background noise issues. Slide. Across the UK, water mains stretch for 350,000 kilometers, but this only accounts for pipelines that are owned by utilities. Pipelines leading from mains to a home and from plumbing inside a home fall under the ownership of a customer. However, leakage in these pipes is counted in the reduction targets of utilities. Estimates show as much as 25% of total leakage occurs in supply pipes, but since 56% of customers do not know it is their responsibility to maintain these pipes, leaks can go unnoticed for years. Slide. We believe that our residential water leak detection system has great potential to be applied in the water distribution networks to help solve this. By moving our sensors further upstream in the supply network, we can save even more water than before. The installation is simple. Dig a hole at the supply pipe, drop the sensor in, and fill over top. Our sensors are ideal for supply lines because of the challenges they bring. A variety of environments, pipe materials, and lengths make the flexibility of our design a great asset. Low cost and easy installation also enable quick and scalable deployment. Most importantly, eliminating the need for battery replacements means the sensors do not require regular disruptions to the property owners. Slide. To accomplish this, we can adapt our initial current residential sensor model to the supply pipe environment. We can modify the enclosure design to be suitable for underground use and switch wireless technologies to achieve longer range, more reliable communications in underground sensing scenarios. The functionality from a user perspective remains the same. An active sensor alerts you via the cloud when a leak occurs, instantly giving a location where maintenance is needed. Slide. We're an experienced team of experts in materials, electrical and mechanical engineering, R&D and manufacturing, and IoT and wireless systems. We're confident we're the right team to tackle leakage reduction issues. We hope to partner with a UK-based leakage reduction or utility company in a collaborative effort to realize our technology's potential. Our team could greatly benefit from the expertise and knowledge of leakage and water industry experts in development of our sensor and wireless system. After a redesign of our system, we would look to conduct pilot projects and scale our leakage applications out. Slide. Right now, at low volumes, our residential sensor unit sells for £30 each and is designed for short-range indoor applications. We're confident that at high volumes, with our next generation electronics, our utilities version can sell for as little as 15. We estimate at a 3-meter resolution, this would be £3,300 per kilometer of pipeline for the sensors, or £10 to £30 per home. Slide. With this system, everyone stands to benefit. Utilities can more easily meet targets and enjoy a lower maintenance solution to active leakage control. Customers can save on water bills and have lower risks of water damage from leaks. And for the UK, visible action on supply lines can encourage users to consume less water within their own homes. Slide. We are AquaSensing. We have an affordable, scalable, green leak detection sensor. We're growing into the utility space to save even more water, and our team is looking to collaborate with UK-based experts on leakage and water supply. Thank you.
Can I just check, is Nathan available for questions at all or not? He's... Nathan, thank you very much for that. Fascinating. Let's go through some questions straight away on that one. So we've got a question here on Slido, which is, what sensor are you using? What are you actually detecting?
Yeah, so our work kind of started as a research project at the University of Waterloo, and we were working on moisture-based nano generators. So we have a nanomaterials device that produces power when it comes into contact with water. So we're actually relying on the water contacting our sensor device, which also acts as our power source, if that clarifies it at all.
Yeah, no, that's fine.
Okay, cool.
So one of the other bits that we're looking at is and another question's come in, have you considered minimizing false alarms by only reacting to chlorinated water as opposed to groundwater? And I think that's the bit where you were talking about sinking a borehole or a chute down onto the pipe and having one of these sensors there. Obviously in the UK, we quite commonly will get groundwater, and in fact, having been to Canada, I know that you quite commonly get groundwater as well. Is there any way that you could configure this system so that it would only react to a certain type of water? Or
yeah, for sure. So we could, probably the easier thing to do would be integrate an additional sensor for detecting whether the water is chlorinated or not. Or like you said, you could adapt some kind of mechanism to differentiate between the two types of water. That would be something we'd be looking to add onto the sensor we already have developed for the residential application.
And are you able to share more about the IoT technology? So you mentioned that you're using IoT technology. A number of us in the room here have kind of experimented with that. And we know that there is, although IoT is a step forward and a great change from where we were with GPRS, obviously there's still some issues in terms of getting signal from below ground. Have you done any trials on that? What's your feeling in terms of getting signal out?
Yeah, mostly so in terms of getting signal out, it's research onto what technologies would be viable right now. We haven't done any sort of underground testing. This is more of, I guess, a proposal as to what we believe we could apply our technology to. But currently what we use for the residential space is Bluetooth, which obviously is a much shorter range technology. However, we could easily change what we're using for our wireless communications to some of the longer range ones.
Yeah, and I think that's, it's that kind of fit and forget aspect is quite interesting as well. So you were talking about, burying this in walls as well, and things like that. Do you actually, how robust is this sensor? One of the questions we've got coming in, how would it work in heavy clay soils? And I think there's a dual bit there of number one is that might be that moist atmosphere, and obviously we'd be looking to detect the chlorine, but it's also, those can be quite aggressive as well. Are you satisfied that you're able to get the longevity out of this sensor?
Yeah, we believe so. The idea, the whole selling point behind the sensor for the residential space is the longevity, right? So you could take the sensor, put it somewhere, and some are completely inaccessible even in the middle of construction. That's kind of what we're going for. Because you don't have to go in every 5 years or sometimes even 10 years still to swap out batteries. So you can hopefully get much higher coverage with this device because you don't need to actually access it until the water leak actually occurs.
Thank you. And we've got a question coming in here. What separates you from something more familiar to us, like Hive sensors under the sink? And I think, for those of you that don't know, the Hive sensor is this little thing, literally, that's looking for moisture, but sits under the sink. I think, and without putting words in your mouth there, Nathan, is the key bit here is that battery-less technology. Obviously, Hive does require a battery in it. You're saying we don't require a battery. And in addition, you're looking to actually move this thing outdoors.
Yeah. Well, I think the key difference between Hive, I'm not familiar with Hive, but I'm familiar with lots of battery-based water leak sensors. They're okay in terms of a single home. If you think of your smoke alarm or something, in Canada we have to replace the batteries every 6 months or a year, something like that. So that's fine if you're a single person in a single home. But when you think of huge commercial properties or apartments that are rented by a management company, the logistics to change batteries in 1,500 residential units in 7 different spots at regular intervals just becomes unsustainable. You can't really scale with something like that, and that's the idea of having the battery-first technology, is you take away a lot of that pain from someone who's using it.
Oh, that's fascinating. Thank you very much, Nathan. What we're going to do is we're going to go into a time of open questions now. How long have I got, Bob?
Just a couple of minutes, Jez.
Oh, okay. So in that case, I'm going to ask each of the 4 of you, I'm going to ask you to give me one. I'm going to ask one question. I want a quick, 10-word answer from each of you, okay? You've managed to get in front of all of these people, okay? And kind of explain your innovation, which is absolutely fantastic. Could you give one bit of advice to other people that want to get in front of the water industry? How do you get in front of the water industry and convince them to start looking at your device? So I'll work along the line. Khaled, any advice for people?
Oh, gosh. Look, don't be scared of models and predictions. Eventually, when you start trusting your predictions, a leap of faith, you will realize that there is a return there somewhere in the near future.
Thank you. Brad?
I'd say literally just don't be scared to reach out to people. When I started with Electroscan UK in 2019, it was relaunched. From the UK, I had no contacts at all. I remember sat at my dining room table thinking, how the hell am I going to do this? To where I am now, and it was literally just because I said to myself, don't be scared, reach out to people, find the network, find the contacts, and then just ask for advice on things we don't understand.
I'd say 2 things, Jez. Firstly, make certain to put put yourself in the shoes of the person that you're selling the idea to, and absolutely, leverage the maximum value that they're potentially going to receive from the innovation. But secondly, don't try and perfect something before you tell them about it. Sort of pretty much 60-70% good is good enough.
I love
to get
that.
going.
Yeah.
To get going. Don't try and be perfect.
Thank you. And Nathan?
Yeah, along the same kind of lines, just kind of get your ideas out there for people to listen to. The way we ended up here was also by pitching at the Water Dragons event a couple weeks ago, and then, we've just been getting good feedback from that. So.
Thank you to the 4 of you. Can we have a round of applause, please, for these 4? Well done, guys. Please, look. They've taken time out from their busy days to come here. I'm sure they've had an excellent conference, but this is their businesses. This is what they're trying to do. Do take the time. If you've been listening to what's been said and things like that, and you want to have a chat with them, seek them out, go and find them, have a chat with them, find out what they're doing, and help these companies. Let's make Leakage Innovation in the UK a place where companies want to come to work. Yeah, where we attract the best in the world, because people go, you know what, if you pitch in front of the UK water companies, they listen, they come and talk to us, and they help us develop solutions. So do come and have a chat with these people here. Thank you. Bob, back to you.
And thank you, Jez, for chairing this session, and thanks from me also to the 4 of you. Great session. Thank you very much indeed. Right, now this next bit is going to be really challenging for everybody, because we've got literally a 5-minute break here for everybody to literally run outside, grab a drink, go to the loo, whatever, back here in 5 minutes. Are you up for that? Yeah, go.